You have queried Deep Space Explorer for a survey of solar system resources. Centerpiece of this celestial census is the Sun, a G-type star in the astronomer's encyclopedia. Although it's technically a yellow dwarf, the Sun is a bit larger and brighter than the average star in its class. A fusion furnace converting hydrogen into helium, with a 10 billion year fuel supply. Today's Sun is about 1,329,000 kilometers in diameter. Its temperature at the surface, about 6,000 degrees Kelvin. Occupying the system's inner orbits are 4 small rocky worlds: Mercury, Venus, Earth, and Mars. Composed primarily of high-density compounds, metals in astronomical terms, all 4 have solid cores rich in nickel and iron. Radioactive elements, originally ginned up in the alchemical fires of ancient supernova stars, provide subterranean heat sources. Within at least one of these worlds, the Earth, this power is sufficient to drive active plate tectonics. Return here in 10 million years, and you shall see a different landscape. Atmospheres, ranging from barely detectable, Mercury, through too thick to breathe, Venus, surround the hard surfaces of these spheres. All 4 continue to be bombarded and accumulate meteoritic material, a constant rain of stony iron and ice. One source of this rubble is the asteroid belt, millions of irregular bits and bobs, from sand grains to the size of cities tens of kilometers across. Some are dark and rich with organic materials and water. Others are high-grade nickel steel of such purity as to make a swordsmith weep. Sufficient resources for a space-based civilization of hundreds of billions of people. Humans have just begun their love affair with these nodes, the first robotic prospector touching down on 433 Eros, a motherlode of iron and silicon. The belt itself is the memory of a planet that never coalesced. Tidal forces from the large worlds further out forbid the orb from forming. Those large worlds are of a different order. Gas giants, hundreds of times the size and mass of the terrestrials, with no definite crusty surfaces below their colored bands of clouds. These are the Jovian planets. Jupiter's staggering size, 142,800 kilometers in diameter, conceals a world that is poor in the elements necessary for life, and its violent atmosphere is hardly hospitable. Jupiter's signature feature, the Great Red Spot, is a typhoon larger than the Earth in diameter. Gas giants tend to form ring systems. Each of the 4 has one. Circlets of small, icy material. But none, of course, can approach Saturn's rings for sheer beauty or number. More than 1,000 individual rings are defined. Embedded within the complex, several tiny moons. Each of the mighty quartet is attended by many moons. Saturn has at least 30. Uranus, a drop of water 4 times the diameter of Earth, has more than 20 confirmed moons, and all are tipped and tilted over, as is Uranus itself rotating on its side, the result of a titanic comet strike in the planet's ancient history. Some of the moons out here are huge. Jupiter's Ganymede and Saturn's Titan are larger than the planet Mercury. Neptune's enormous moon, Triton, probably formed much farther out in the system, but was captured by Neptune long ago. Eons from now, Triton will crash into Neptune. Neptune's stormy methane-blue atmosphere hosts the highest winds in the solar system, blowing up to 2,000 kilometers per hour. A great dark spot, like Jupiter's, was photographed in 1989, but by 1994 had completely disappeared. Beyond the orbit of Neptune, another band of rocky objects orbits the Sun. There may be as many as 100,000 of these Edgeworth-Kuiper belt objects that are larger than 100 kilometers in diameter. Also called trans-Neptunian objects, most fly in nearly circular orbits, taking hundreds of years to go once around the Sun. But a few, perhaps 50, occupy highly elliptical orbits, tilted out of the plane of the planets. Best known of these so-called centaurs is Pluto and its companion, Charon. Most of the well-known comets, like Comet Halley that reappears every 76 years, were probably trans-Neptunian objects. Long-period comets, passing by but once, never to return, may originate in a halo of objects, surrounding the system of the Sun 1,000 times beyond the orbit of Neptune. You have come to the Oort cloud, leftovers from construction of the solar system. Is this family typical of all stars, like the Sun, or a unique, odd, erratic of creation? Humans cannot know until other stellar locations have been examined, probed, and compared to these, the jewels and the junk of the solar system.